Hello, good evening. Hi, Gabriel. You're the only one here today. All right, so let's continue with our chemistry revision today. Okay, I think we stopped around here, which is our chapter 6, our material properties. All right, so very simple chapter, very short chapter. So I'll quickly go through this, then maybe we can even go to another chapter by today. Right, so matter is made up of tiny particles called atoms. You already know this, right? When we zoom into something really small, we see atom, all right? And then a substance that is only made up of atom is called an element. You will learn about this in year 8. Okay, so what does this mean? That means if I have a piece of gold, inside is only made from gold atom. There's only one type of atom in a gold bar. So a gold bar is an element. Gold is an element, right? Because there's only one type of atom. So we have 118 atoms here. Think of them like Legos. Okay, think of them like Legos. So you have 118 types of Legos, right? Because different Lego blocks you can put together and make, complex stuff, right? So that's the same thing. All right, so around us, we have 118 elements so far, right? Who knows, we might discover another one again, we'll never know. You should roughly know where is everything. Not to say where is everything, you should know metal is on the left-hand side. Okay, you see the blue is metal. Besides this hydrogen right here, and then the right side is non-metal, and this hydrogen. And this middle fella, the green ones, we call it metalloid, okay, or we call it semi-metal because they sort of behave like metal and non-metal. They just kind of, act a bit weirdly because they behave like both. Right, anyway, let's continue on this. The main point of this chapter is to learn what's the difference between metal and non-metal. Okay, so this is very easy to understand. Pretty common sense if you ask me. So metals, they are shiny, they are ductile and malleable, means you can beat them. Ductile means you can pull them into any shape. Malleable means you can beat them into any shape. Okay, whereas metals, they're brittle. Okay, that means you try to bend them, you try to hit them, they will scatter, they will break. All right, and then metals, they have high tensile strength, they are very strong. Non-metals, they are weak. Metals, they are good conductor of electricity and heat. This is why we use metal for wire, for pots, your cooking pots, because wire, we need good conductor for electricity. Pots, we need to be good conductor of heat. Whereas non-metal, they are poor conductors of both, right? They are poor conductors of both. Non-metals, they are mostly insulators. They cannot conduct electricity. They cannot conduct heat. Besides carbon, you see, carbon is the only non-metal, as in terms of element, they are the only non-metal that can conduct electricity. Only. You see, carbon cannot conduct heat. What is carbon anyway? Carbon is your pencil tip. Okay, your pencil lead. This is not lead actually, this is carbon. All right, so your pencil lead can actually conduct electricity. Not heat though, right? Not heat though. Carbon is a bit special. All right, and of course, metals, they have high melting and boiling point. Non-metals, they have low. Metals, they are high density. That means they will sink in water. Non-metal, they will float on water because they have low density. All right, simple. Really, really simple. So these are a few common metals that we use. Okay, what is iron? We use it for tools. Okay, we use it for building. Right, your house is made from iron. Even cars, okay, you can even say vehicles. Okay, cars are made from iron too. This is why they rust. You see, your car will rust if you don't paint it. This is why most of our car is painted. And then aluminum, we use it for wire or foil. Okay, this is the aluminum foil. Copper, there's only one use. We use it for wire because they're very good conductor of electricity. Zinc, we use it for roof. Right, I'm sure you have seen this kind of roof before. Okay, this is your zinc roof. really noisy when it rains. All right. And then of course non-metal, we have iodine. They are your antiseptic. That means you put it on your wound. If you cut yourself, you put it on your wound so that they can get rid of the bacteria. Chlorine is for bleach. All right, you use it to bleach your clothes. Your Clorox is chlorine. Yeah, that's why the name Clorox. And of course, sulfur, we use it to harden rubber. Carbon, like I said, carbon is your pencil lead. Your pencil lead is not lead. There's another type of metal called lead, but this is not lead. All right, it just looks like it. Anyway, so we have one more thing called alloy. Okay, what is alloy? Alloy is a mixture of metals. Okay, I'm just going to put a short remark here. Mixture of metals. When you put a few metals together, they become harder. They become stronger. They become more durable. Right? This is why we use steel. Okay, in fact, your car is not made from iron. Your car is made from steel. Okay, but steel is just iron plus a few more, other elements. So steel, your building is made from steel, bridges are made from steel, vehicles, frame, railway tracks, many things are made from steel. Okay, the thing about steel is they're hard, and they're cheap. Steel is really cheap. This is why we use it for our cars. Next, bronze, we use it for metals. Brass, we use it for keys. Okay, and musical instruments. The trumpet is brass. A trumpet is made from brass. And then duralumin. This is when you see aluminum, this is aluminium. Because they are so lightweight, so we use it for aircrafts. We use it for planes. All right, so that's about it. That's about it. Very easy chapter. Okay, so I'm just gonna fly through this. So A, match the term with its correct meaning. By the way, we're on page 5. So match the term with its correct meaning. So what is element? Element, like I said, is a substance which consists of one type of atom only. One type of atom only. Right, about the next one, this compound, you can actually don't need to care about this because you actually learn this next year. Okay, that means there are more than one type of atom. More than one type of elements. Right? One Lego is called element. You put 2, 3, 4 together, we call it a compound. All right, so identify elements and compounds. So your lead is an element. Okay, they should draw it in one ball. They should draw it in one ball. They should draw it like this. Okay, you might say, sir, what are all these dots here? These are electrons. Okay, you don't need to know. Same goes this S here. Right, when you see 2 here, you see hydrogen. This is one Lego. Chlorine is another Lego. So you have 2 types of Lego here. So this is a compound, which you will learn it next year. Right, next, your salt is also a compound because there's 2 here. And then the last one, sulfur. This is an element. Okay, an element because they're atoms too. Right, next, number 2. Okay, number 2. This one is okay. This one is not really coming out for exam because it's a bit out of your syllabus. But this is. Alright, let's look at number 2. So you have an experiment to study the conductivity of electricity. So you have 2 circuits here. You have 2 circuits here. You have a copper rod. Okay, as you know what copper is. Okay, copper is this thing. Okay, that's a copper. So well, obviously we know copper is a conductor. And then the next one, they put sulfur here. Okay, they put sulfur here. So what is sulfur? Sulfur is a type of yellow powder. Okay, as you know, you see powder, they are non-metal. Okay, so this is a metal. This is a non-metal. So you can guess what's going to happen lah. When you connect this switch, okay, the circuit will be connected. Okay, since this is metal, right? They can conduct electricity, right? They can conduct electricity, right? So this light bulb is going to light up. All right. Whereas non-metal, this bulb will not do anything because there's no electricity here. None. Nothing. whatsoever. Right? So kindly ignore the Malay, okay, because it's taken from a dual language book. Right? So copper, complete the observation when the switch is turned on. Right? For copper, the bulb lighting, this should be lighting. Okay, so it lights up. Okay, it lights up, whereas sulfur, you can say it does not light up. Right? It doesn't light up. So the type of material, as I wrote it in the question, copper is a metal. Sulfur, it's a non-metal. All right, metal and non-metal. So explain your answer in A. Why does it light up? Okay, why does metal light up? Why does non-metal light up? They want you to explain. Okay, you can say because metal is an electricity. Okay, hang on, let me rephrase this. Is a conductor of electricity. Non-metal is not. Right? So they want you to explain why. Why does metal light up? Okay, because it's a conductor, whereas non-metal is not a conductor. Okay, this is primary school stuff, right? Right, see, suggest one other material that can replace copper and sulfur. Right, so who can replace copper? Any metal. Okay, I can go for aluminum. Okay, aluminum. Any non-metal, any metal will do. So what about sulfur? You can replace it with iodine. Right, there's a list for you to choose here. There's a list for you to choose here. So here's the thing. Why do I pick these few metals to let you learn? Because they are quite common. All right, because they're quite common. They have very long history. They are amongst the first few atoms that we humans discovered. Right, they have like hundreds of years of history. In fact, like iron, iron has a few thousands years of history. Okay, we have been using metal to iron to make what swords. Okay, since wartime. Okay, we use it to make cannons. So it's been around for quite a while. Right, so these are the few that you should know. So there should be no problem for you naming, another substitute. Okay, so D, both of the rods are then hit with a hammer. What will probably happen? Right. As we know, metals, they are ductile. That means malleable. That means you can beat it into any shape. Whereas non-metal, you beat it, they will shatter. They will break. Right. So what's gonna happen? Okay, what will probably happen? So you can say copper rod bends. Okay, copper rod bends. The copper will just bend. Whereas your sulfur rod breaks. Okay, sulfur rod breaks. The sulfur will just break. Okay, break in tiny pieces, just like your pencil lead. Okay, just like a pencil lead, you hit it, it breaks. So E, if copper rod is replaced with carbon rod, predict what happens when the switch is turned on. So, like I said, carbon is a conductor. Your pencil lead is a conductor. In fact, right, your battery, your AA battery, the battery in your remote, if you cut inside your AA battery, right? Okay, so let me show you this. Right, if you chop your AA battery into half, you see this middle rod there? The middle rod is the carbon, the same as your pencil lead. There, you see, there's a carbon rod inside. There's a pencil lead in your battery. So because they are conductors, that's why we use it in batteries, and it's cheap. Okay, carbon is very cheap. So if copper rod is replaced with carbon, pretty what happens? So the light bulb, the light bulb lights up. they also light up because they are good conductors. Oops. Right, easy. So next, number 3. This is a little bit unrelated to you, but I think it's good to know. As I said, you should know where they are. Okay, you should know where they are. As I said, the right-hand side is the metal, besides this tiny fella here, and then the right side is the non-metal. So you can roughly know X is a metal, Y is a non-metal. Right, do not ever memorize the periodic table. Do not, I repeat, do not. From year 7 all the way to A levels, there is no need to memorize your periodic table. Okay, I took A levels, even I don't memorize periodic table. Who the hell remembers periodic table? You just need to know, what elements are they? Okay, what type are they? Okay, you just need to know where's the metal and where's the non-metal. That's all. They won't ask you, okay, say magnesium, where's magnesium? Oh, magnesium is here. No. They don't ask things like that. So please don't memorize. Right? Unless it's it's your interest, like you feel like challenging yourself, you want to memorize it. Go ahead. Right? So X, it's a metal. Y is a non-metal. Easy peasy. So B, what are the differences? Oh my god, there are so many. First of all, X is it's ductile and malleable. That's the first thing I can say. You can just write one lah. You don't want to write two, you can write one, ductile. And Y is brittle. They can break easily. What else? You can say metal, they have high melting point or boiling point, whereas Y has low melting point, boiling point. Metal melts at very high temperature. For example, 1000. Okay, what else? I'll try to pick the short ones to write lah. X is shiny, Y is dull. As you know, metals, they are very shiny. Okay, try to pick short points lah. I mean, if you want to say a good conductor of electricity and heat, yeah, sure, go ahead. But why write so long just to get 1 mark, where you can write such a short answer to get another mark? Okay, there's nothing wrong being lazy. Yeah, there's nothing wrong being lazy. So just be lazy. All right. It's not called lazy, it's called being smart. You don't need to write so long just to get the same marks. So C, iron, or what we call ferrum. Okay, why is there ferrum here? Ferrum is the scientific name for iron. Between X and Y, which is most likely iron? Well, of course it's X. Cannot be Y. Okay, next, moving on. Let's go to number 4. Oh, what an easy question. So a group of students conducted an experiment to investigate the heat conductivity of substances, copper and glass rod, heated simultaneously. So there's a copper rod here. Okay, at the end there's a thumbtack stuck to it with wax, and then there's another glass rod. Same thing happens here. So when I heat it, the heat will be conducted to here, and then the wax will start melting, and then the thumbtack will drop. Right, so as you can see, for copper, it takes a really short time. It takes like what, 3 minutes, this thing will drop. Whereas glass, hey, glass ain't bad. At least it drops. Okay, so from here, we can see that glass is not a very good conductor. Okay, they're not a very good conductor. I mean, they still conduct, but it's not a very good one. So, which is a good conductor of heat? Copper, yes. Glass, no. All right, so B, write true or false for the statement below. Glass is malleable, while copper is not malleable. Okay, we said just now, malleable means you can hammer it into any shape. Can you hammer glass? No, you can't. So false. Okay, and then B, copper has high tensile strength. Glass has low tensile strength. Yes, of course. All right, tensile strength means how strong they are. Okay, how strong they are. This is why they use metal like iron to make your car. Your car is made from iron or steel, if you would. Okay, so why steel though? Because like I said, steel is very strong. Steel is very strong. They do this to protect you. If your car is made from steel, all right, if you are inside and there's an accident, nothing will happen to you. Not to say nothing lah, you have lower chance of getting injury or death, right? So this is why they use metal. So C, copper is used in the manufacturing of electrical wires. Okay, so this is your wire. If you remove that insulator outside, the rubber, you cut it away, you see these metals inside. So explain the properties of copper which enable it to be used for this purpose. Why use copper? Because copper is a good conductor of electricity. Right? So you might say, sir, I thought all metals can be used. Technically you can, right? Technically you can. But out of all the metals, copper is one of the best conductor. All right, of course, they are better than copper. You have gold, you have silver, right? Why don't we use gold then? Because just in case you don't know, gold is really expensive. Not to mention, gold is very heavy. All right, the good thing about copper is cheap. Copper is there's plenty of copper going around. Okay, very easy to get copper, and of course, copper is very lightweight. Okay, so if you use copper to make wire, the wire wouldn't sag. Okay, it wouldn't sag. You see those TNB thing, right? Have you seen those tower before? You know, sometimes when you go on highway, and you see this tower, right? And you see wire hanging, right? So they're made from copper, that's why they're lightweight. If they are made from gold, they will sag all the way to the ground because they're so heavy. So it will make no sense. Okay, this is why we use copper. Out of all the metals, we use copper. So number two, why are gold and silver used for making jewelry? Okay, that's a very good question. Because they're shiny. They're shiny, they're bling bling. All right. And for the longest time, shiny usually means expensive. Okay, shiny usually means a status, right? This is why gold and silver for the longest time, even till today, it is used to flex your youth. Okay, to tell people that you're rich, just in case they don't know. So that's why we use gold and silver, right? To put the bling bling on you, so that you look rich. Right. Anyway, so that's it, chapter 6. So let's jump to unit 7. Okay, I know I'm moving a bit fast, but I have to, okay, because I don't want to waste time. So unit 7 is your acid and alkali. Right. This is a very important chapter. Please pay attention, especially this chapter, because your exam will be asking a lot on this. They should be. All right, because next time when you go chemistry, you'll be learning this again, but in details. Right? So what is acid and alkali? So as you know, acid is anything that's sour, like your lemon juice. Alkali is anything that's bitter, like your soap water. Okay, so pH value, acid is less than 7. Right? Just think of it this way. We have our pH scale, 7 being the middle, 14 being the most alkaline, 0 being the most acidic. So anything less than 7 going towards the left side, that's acidic. Anything that's higher than 7, anything towards the right side, that's alkaline. Right? So acid, they're sour. Alkaline, they're bitter. Both are corrosive. That means they can eat away your stuff. You put a piece of paper in strong acid, they will corrode. They will be gone. You put a piece in strong alkaline, same thing. Next, litmus paper. Acid turns blue to red. All right, alkali turns red to blue. Now, this one you have to know, which I believe you learn in primary school. Next, examples. You have two types of acid actually. You have the organic acid, which is weaker. Okay, you can put a remark here. Inorganic acid, they are usually stronger. Right? Weaker as in, you put it on your skin, it won't hurt. You drink it, it won't hurt. Like for example, citric acid, This is the acid found in your lemon juice or any citrus fruit, any sour fruit, you will have this. All right, tartaric acid, acetic acid. This is in your what was it again? Vinegar. Okay, your vinegar, the vinegar your mom used for cooking. Okay, that's your acetic acid, right? And then of course you have your ascorbic acid. This is your vitamin C. Lactic acid, the acid found in your muscle when you work out, right? When you when you lift weights, right? I don't know whether you notice this. When you lift weights or when you run, when you push your muscle to the limit, when your muscle is going to fail, there's this very sore feeling that you want to stop. That's because of the lactic acid, right? It's a signal that your body is telling you, bro, this is the limit. I cannot go on too long. Okay, you need to stop, right? So it's a sign that your body say they cannot take it anymore. And of course, these are weak acids. They're not going to hurt you. But inorganic acid, they are much stronger. They are mostly for industry. Okay, inorganic means they're not from living things. So they are much stronger. Okay, so don't mess with these things. So you have your hydrochloric acid. You use this to wash bathtub, in fact. Nitric acid, you use this to make bombs. Okay, sulfuric acid, you find this in your car battery. Right, very strong, very corrosive. And of course, examples. Alkaline, you have your sodium hydroxide, potassium hydroxide. You use these for your soap. Okay, for your soap. Calcium hydroxide, you use this for your, we call this lime water. Okay, we call this lime water. Ammonia solution, this one we use it for, you know, I'm not going to tell the function. You need to know these two. They are quite important. All right, so next, detecting acid and alkalis. How do you detect acid and alkali? How do you know whether something is acid or alkaline? We use something called an indicator. All right, to indicate whether something is acidic or alkaline. Because you see, we can't be tasting it with our mouth or touching it because it can be very dangerous. Okay, do you taste battery acid? No, you don't. All right, so detecting an unknown acid or alkaline by touch or taste can be dangerous. This is why we use an indicator. Okay, we use an indicator. So an example is litmus, right? I'm sure in primary school, you learn litmus paper, right? You learn this, right? As we mentioned just now, blue changes to red, that's acid. Red changes to blue, that's alkaline. But here's the thing. For a weak acid, they will do the same thing, blue to red. For a strong acid, they will also do blue to red. So this is why litmus paper is not very useful. Okay, litmus paper is not very useful because it only tells us how is it an acid or an alkaline. Okay, they just tell you, okay, this changes color, this is acid, this is alkaline, but they don't tell you how strong are they. All right, so just because they tell you, let's say this is an unknown acid, you put litmus paper, they change color. Yes, sure, I know this is acid, but I don't know how strong are they. Can I touch it? I don't know. Right? So this is why we don't really use acid or litmus, because litmus is kind of useless. Right? So litmus, there's actually two types of litmus. We have liquid litmus and we have litmus paper. So litmus is purple in neutral solution. Okay, so in acidic condition, litmus turns red, blue turns red, and in alkaline condition, litmus turns blue. Okay, red turns blue. So they have both sides. So we don't really use them. We don't really use them. So there are some natural indicator that we can use. Okay, some natural indicator, as you see the picture here. What is this? This is your purple cabbage juice. Okay, your purple cabbage juice. Since the name says purple cabbage, they look purple in neutral. This is pH 7. Okay, when they go acidic, less than 7, which is like vinegar, they turn into pink. All right, and when you go baking soda, which is more than 7, which is like alkaline, they will turn blue. So you see, this is like a natural indicator. Okay, like a natural indicator. Because many things can also work as an indicator. Like this thing called the hydrangea flower. This is really cool. Okay, this is really cool because they turn pink in alkaline and they turn blue in acid. So you can kind of change your soil. If you want your hydrangea flower to change color, you can change your soil pH. Okay, you can put some acid and turn them into blue, or you can just let acid rain turn them into blue. All right, you know what is acid rain, right? Okay, because we have acid in the rain because of pollution. So when that acid drops onto your soil, your flower will turn blue. And if you put some baking soda on it, they will turn pink. Right? So you see natural indicators. Okay, so you can make a few bunches of flower and you can make them any color you want, right? By changing the pH. So next, the best way to tell whether an acid is strong or not, an alkaline is strong or not, right? We use something called a pH scale. Like I said, it goes from 0 to 14, 7 being the neutral. Okay, 7 being the neutral. The more left-hand side you go, it's acidic. The more right-hand side you go, it's alkaline. All right, so pH runs from 0 to 14. The closer to 0, the stronger the acid. The closer to 14, the stronger the alkaline. So this is the strongest acid. This is the strongest alkaline. All right, so for example, let's look at this. You don't need to memorize this. I'm just telling you this for fun. As you know, milk is acidic. You see, when you taste milk, right, they kind of taste a little bit sour. You might say, Sir Godman, how is milk sour? When you ferment milk, when you put yeast into milk, sorry, not yeast, when you put lactobacillus into milk, that is the type of bacteria, you put it into milk, you ferment it, they will kind of turn more sour. Okay, they turn more sour, which becomes your yogurt. All right, this is why when you eat yogurt, they will taste sour. I'm talking about pure yogurt, not those flavored, sugar added yogurt. I'm talking about healthy white color pure yogurt. They are sour because milk is already sour. They make them even more sour. All right, so as you can see, milk is a weak acid because it's very close to 7, right? This is water and salt. And then 4 is a okay acid, not too weak. Okay, certainly stronger, but not too strong, like lemon juice and vinegar. Right, so when you drink lemon juice in the morning, will it hurt your stomach because the stomach is acidic? Yeah, a little. Okay, it will hurt a little. Whereas your hydrochloric acid is here, this thing is freaking strong, right? It's freaking strong. We usually use hydrochloric acid in industry, and believe it or not, inside your stomach is actually hydrochloric acid. All right, your stomach has hydrochloric acid, this really strong acid. You might say, what is it doing inside there, sir? That thing is to kill bacteria for you. Let's say you eat certain nasty stuff, certain dirty food. Maybe you won't get food poisoning. Maybe you will, but maybe you won't. Why you won't get that? Because your dilute hydrochloric acid inside your stomach is already killing bacteria for you. Which is a good thing and a bad thing. You see, hydrochloric acid in our stomach helps us kill bacteria. That's a good thing. But if you stay hungry for too long, if you starve yourself for too long, this acid will start to eat away your stomach and you will get gastric pain. All right, so don't let this thing sit in your stomach too long. How do you do that? By not starving yourself. All right, because when you have food in your stomach, your hydrochloric acid has something to digest, then it wouldn't hurt your stomach. Right, next, 7. And then above, we have blood. Our blood is very close to 7. In fact, blood is around 7.4. Our human blood is 7.4, which is slightly alkaline. Very, very weak alkaline. Okay, you must be like this because it's to help you survive. Toothpaste is a weak alkaline. Okay, when you brush your teeth, that's why it's safe to put in your mouth. Lime water is 10. Okay, bleach is 11. This is where it starts to get strong. 14 is freaking strong because it's an oven cleaner. What is this thing? Don't let this touch your skin, please. Okay, I don't know whether you have this at home. If you have a cleaner, if you have an oven, you'll be buying this to clean off your oven. This is freaking strong. It will hurt your skin. So don't let it touch your skin. Please use glove. Right, that's your oven cleaner. Okay, so these are the acid and alkaline that you should know. Okay, the pH scale. And what is neutralization? Right, this part is, I can't stress this enough. This part is very important. Very, very important. Almost certainly coming out in exam. Right, so what is neutralization? When acid and alkaline, they meet, they kind of cancel out each other. We call it neutralization. Okay, it's like -5 plus +5. They just kind of, become zero because they cancel each other out. So this is what we call neutralization. Okay, so when an acid mixes with an alkaline, they carry out a chemical reaction called neutralization. So they kind of neutralize each other. Neutralization process, produces a neutral salt solution. So please memorize this. Very, very important. Okay, so when acid and alkaline, they meet, it will turn into salt and water, which is neutral. Okay, neutral. Acid and water, salt and water, they are not acidic, they are not alkaline, they are just neutral. They don't do anything, right? They are safe. So neutralization can be carried out in the laboratory using a technique called titration. Okay, please highlight this word, titration. Neutralization and titration, they are very different. They are very different. This chemical reaction is called neutralization. Okay, but this experiment, I don't know whether you do this in school. Okay, I hope you do. Maybe you don't learn this year, I don't know. So this process, this experiment, this step, this technique, this thing. Okay, what is this, by the way? This top one is the burette. And we have a conical flask here. Right, and usually it looks pink here because there's an indicator to tell us whether something is neutral or acidic or alkaline. So by dropping something in burette into a conical flask, this thing is called titration. All right, the reaction inside, let's say this is acid. Okay, up here is acid, down here is alkaline. When they meet together, they neutralize each other. This process is called neutralization. Okay, the process is called neutralization. Okay, the technique, this thing you do, it's called titration. So please don't get confused. All right, because it will be coming out in the exam. So an acid in the burette is slowly added to an alkaline in a conical flask. They slowly add it in here. Universal indicator. So usually we use something called a universal indicator. You might say, sir, what the hell is this? It looks something like this. Okay, can you see the color just now? You see, neutral is green. The more you go towards acid is red. The more you go towards alkaline is purple. Can you see this is rainbow? Okay, red, orange, yellow, green, blue, indigo, violet. This is rainbow, right? So this is your universal indicator. Okay, they are like your litmus. They exist in the form of liquid, or they exist in the form of paper. This is your universal indicator. All right, they can be in the paper form like this, or they can be in the solution form. See, they change color according to your pH. So we use universal indicator here to kind of tell us what's the pH. So it's added to the alkaline in the flask to show the process of neutralization. All right, so at the beginning, you should see purple here. Beginning, you should see purple because beginning, it's alkaline here. It's alkaline here. And then how do you know when to stop? You stop when this thing turns green. Right? Because as you know, green is neutral, right? When it turns green, when it turns neutral, then you stop. When it turns green, you stop. Right? So, I think they say here, as acid is added to the flask, the purple solution, okay, because it starts with purple, slowly changes to blue, then green. When a green solution is formed, the acid neutralizes the alkaline. Okay, so now green means that's the end point, you stop. You don't add anymore. Okay, so next where do we see neutralization in real life? Okay, in action. So bee and wasp sting, as I said before, a bee sting is acidic. Okay, when you're stung by a bee, it is acidic. So you can put alkaline on it to neutralize it so you don't feel painful anymore. But a wasp sting is alkaline, and this time you need to use vinegar. Right? There's a big difference. Bee, they're usually hairy. Okay, wasp, they are usually not a single hair on them. Wasp is more nasty. Okay, don't provoke these fellas. They are they are nothing to joke with. They are nothing to joke about. Bees, they are okay. Like don't disturb bees. Okay, they give you honey, they give you fruits, they give you many things. Why would you disturb them? Right? Wasp is a different story. Okay, wasp, they are not beneficial for humans. They just exist to piss you off. Okay, they just exist to look ugly. All right, whereas they're freaking ugly. Okay, so different acidity and alkalinity. Okay, so you need to use different stuff. So next, indigestion. When you have gastric, that's when your stomach has too much acid. Okay, too much acid. Maybe you starve yourself, you don't eat, or you just have gastric problem. Right, so indigestion is caused by too much acid produced by the stomach. Now you have too much acid here, so you can neutralize it by using alkaline, which in this case we call it an antacid. Okay, I'm sure you recognize this lah. We sell Gaviscon here in Malaysia. This is an antacid. So next time you have gastric problem, you go to pharmacy, you say, oh, do you sell antacid? If they say yes, we do, that's what you need. Okay, next, baking. So baking, we use sodium bicarbonate. Okay, so we call it baking soda in short. So we add this to bread dough. It reacts with the acid in the dough to produce carbon dioxide. The carbon dioxide will rise the dough. So the more you put, the more carbon dioxide you produce. The more the bread rise, the fluffier it is. Okay, you want your bread to be fluffy, you put more baking soda. Next, toothpaste. Our acid, we have acid in our mouth by bacteria, because bacteria, they're acidic, so they can corrode our teeth enamel, which is this white color thing here. So it will cause decay. So toothpaste, it contains alkaline to neutralize the acid. So you brush your teeth to kill the bacteria so that your teeth stays healthy. Okay, the last one, soil and water. When you have acid rain, as I said, acid rain is a pollution. When they rain down, your soil and water becomes acidic. They can kill plants, they can kill aquatic lives. So what do? You use something called sodium hydroxide. You put it into your soil, you put it into your water, it will neutralize the acid rain. So your water stays neutral. So you don't kill things in the wild. All right, so that's it. As I said, please pay more attention to acid and alkaline. Very important, very important. Okay, even though maybe you don't learn it this year, you learn it next year too. You will certainly learn it in year 10 chemistry next time. So yeah, pay a bit more attention here. So next, number 1, let's do our exercise. Group the following substance correctly. So we have milk of magnesia. What is this? This is actually an antacid. Can you see? Some some medicine, they call it milk of magnesia. So that's your alkaline because you use it to neutralize your stomach. Okay, milk of magnesia. Next, tea. Tea is acidic. This is why tea has that sour taste. If you drink very bitter tea, like oolong, like tikunyam, okay, you know what's tikunyam? Okay, that's the most expensive type of oolong. Or you drink jasmine. Sometimes if your jasmine tea is very thick, very bitter, when you swallow it, it kind of leaves this very acidic, sour taste in your mouth because tea is acidic. Okay, this is why they say if you have gastric problem, please don't drink this on an empty stomach. It's not very good for your stomach. Okay, so next, baking powder. As I said, this is alkaline. You use this to rise your bread. Lime water, that's alkaline. Please don't get this confused. Lime water is not, it's not this lime. Okay, I know it sounds funny lah. This lime is acidic, nothing, no question about that. But lime water, right? Lime water is actually a type of stone water. Okay, not this. Certainly not this. Lime water is this. Okay, lime water is this. Because, why do we call this? Because they are called limestones. Okay, limestone. This thing is alkaline. Not that fruit you eat. So they are alkaline. So next, sulfuric acid. The name already say acid ma. So sulfuric acid law. And then sodium hydroxide. You find this. Okay, funny. This thing I told you to memorize right up there. This thing. Sodium hydroxide. This is used in your soap. Your soap. This thing gives you that slippery feeling. That's why soap they are slippery. Okay, sodium hydroxide. Next, pineapple juice. This is acidic. In fact, they are so acidic, they will hurt your tongue. Right? When you eat pineapple, the first slice is okay, then the second, then the third. Eventually, you start to feel, why does my tongue hurt? Because pineapple, right? Just an extra info lah. Pineapple has a type of enzyme that will corrode your tongue. Okay, and then once your tongue is corroded, the acid will act on your tongue, and it kind of hurts it a little bit. So this is why eating pineapple over a period of time, it hurts. Right? So vinegar, this is acidic. Okay, that's why your vinegar is sour. Okay, easy peasy here. So next, number 2. Take for the correct statement and for the incorrect statement. Concentrated alkalis are corrosive. Yes, they are. Same goes to acid as well. So acid and alkalis only show their characteristic in the presence of water. Yes, right? Very important. If your acid and alkaline is dry, if it is dry, like your dry soap, okay, you take a piece of litmus paper, you put it on dry soap, you don't see anything, because dry acid and dry alkaline, they will not show you anything. Right? So next, strong alkalines have pH less than 7. So less than 7. Nope, this is wrong. It should be more than 7. Okay, so next, dilute hydrochloric acid will react with magnesium. Yes, they do. This one I don't need to know. It's fine. Last one, concentrated acid may be weak acids. Yes, they are. This one you also don't need to know. This is a bit year 10 stuff already. You learn this in year 10 next time. Right, next one. Let's see how many questions do we have. Okay, so you know what? Since Renee is not here today, I'll try to save some for her, because we have 1 more week to finish this. So I'll try and, there's no need for us to rush so fast lah. So mesh the acid and alkaline with their use. So number 1, sulfuric acid. This is used in your car battery. Okay, you know what's your car battery, right? You know what's your car battery, right? Do not throw this into the longkang or anything. This thing is very corrosive. Okay, if you pour this down the drain, you can kill many wildlife. So please don't do this. Okay, they have strong acid inside. I'm sure when your dad, okay, when do we change this? You change this when your car cannot be started. Right? I'm sure when your dad changes this, they will take this out. Yeah, they will take this out, and then they will give it to the shop, because the shop will recycle this thing. So just, don't throw this anywhere. All right, so that's your car battery. So they have sulfuric acid inside, which is very strong. Right, so B, ammonium solution. This is used to prevent coagulation of latex. Okay, what does this mean? What is latex? Latex is rubber before they dry. Okay, this is your latex. What the hell? Liquid latex. Okay, that's a liquid latex. Okay, so when you cut your tree, right? When you tap your rubber tree, this is what you get. Okay, and then they will bring it to the factory. They will dry it up. Okay, and then you get your rubber. You get a rubber sheet. This is how rubber band is made. So that's a liquid latex. So we put some ammonium inside to slow them coagulating. Because you see, if before I send it to the factory, if they coagulated, then my latex has no more value. My latex is like useless. So I need to add some ammonium inside before I reach the factory so that they remain in that liquid form. You know what? This is not important. Just good to know. Right, next, C, citric acid. This is found in your fruit juice. Like I said, any fruits that taste sour, we call it citrus fruit because they have this thing. Then next, sodium hydroxide. Like I said, this is found in your soap. Okay, sodium hydroxide. You can actually buy this from Shopee. If you like to make your own soap, this is what you buy. Okay, you buy this from Shopee, you can make your own soap. And then of course, formic acid. This is in the coagulation of latex. Again, this is not your concern. Not important whatsoever. All right. So you know what? This question 3 is a bit long. So I think I'm going to stop here because I don't think I can finish this by today. Right. So if you have the time, okay, Gabriel, if you have the time, you can go home and finish everything because there's one more remaining, which is the chapter 8 one. Okay, finish everything because I think it's time for you to prepare for your finals, right? I think your finals should be around the corner, right? Should be around end or mid of October, depends on your school. Usually it's around there lah. Okay, so if you have no question, then I will stop here. I will see you next week lah. All right, so have a happy Monday. Okay, I'll see you again. Take care. See you. And bye-bye. Good night.